Okay, so good afternoon. So let us solve these problems. There are three problems, but I designed them when I just taught you the definition of derivative. But on Thursday, we also learned about differentiation rules. All these problems can be solved using differentiation rules much faster. And this is why I will solve every one of them for you in two different ways. One, using the definition, because in national exams sometimes they forces you to do it in that way by mentioning use the definition of derivative and calculate. Yes, but here I haven't mentioned because at that time we only learned about definition. So that was the only way that we could do. Okay, so let us read the first problem. So let me repeat. I will solve each problem in two different ways. One, using the definition, which is also something that you have to learn, which is the long way. But another one using differentiation rules, which is a shorter way. You have to know both of them because in the national exam, sometimes they ask you to use definition of derivative to calculate. So in those cases, you have to respect and do the same thing there. Okay, the first question tells you that this function is given. It's not a complicated function, but you will see that using definition of derivative, it becomes rather tedious. Then 4 times f prime of 4 plus f of 6 is equal to what? We are supposed to calculate this. Okay, so the first thing that I will do is to write a formula for the derivative. Hopefully you haven't forgotten that. Let me write it here for you. So f prime of a is equal to the limit of f of a plus h minus f of a divided by h. The problem here, f of x is given to you. It's 1 over square root of x. And then I am supposed to calculate which question mark 4 times f prime of 4 plus f of 16 is 1. This is just a simple thing to do. F of 16, oh sorry, this is not square root of x, it's a square root of x. F of 16 is very simple, you just replace x with 16. The harder part and the longer one is this part. Okay, so let me do it using this formula. So instead of a, I put 4. So f prime of a, f prime of 4 becomes what? The limit of f of 4 plus h minus f of 4 divided by h goes to 0. Yes? And I don't think that's a very hard thing to do here. The first starting point is the same. F of 4 means go to your function, replace x with 4. If you do that, square root of 4 is 2, so it becomes 1 over 2. So minus sign, 1 over 2. What is f of 4 plus h? Do the same thing. Go to your function, but this time replace x with 4 plus h. So if you go here, take x out and replace it with that combination, 1 will be in the numerator. In the denominator, it becomes x 4 plus h. And divided by h goes to 0. So this part up to here is just the lesson we learned about derivative. In order to calculate this, you need to remember what you learned in first chapter for limits. And I remember I haven't given you an example of this type in the limit. Okay, the one that I gave you was without these ones up there, and it was not that hard. This is also not hard, but a little bit more tedious. So do you know what to do? Because in those cases, I was multiplying immediately by the conjugate rule. The conjugate rule is still relevant, but I prefer not to apply it immediately, because if I ask you how many fractions are involved here, you say this is one smaller fraction, another fraction, and the whole expression is also fraction. So the first thing I will do is to get rid of a lot of fractions and write it as one single fraction. In order to do that, I take the LCD between these two. Okay, so I will copy and paste the limit part, h goes to 0, and then I have h here. So can you tell me what is LCD? Again, we didn't solve these kinds of problems. We only considered about rational functions, but the idea is the same. So what is LCD between these two? LCD is an expression which is divisible by both of them.
2 times square root.
Yeah, 2 times square root. It's not that hard to see. If you really understood the essence of LCD, even though a square root sign is not a rational function, but still the rules are the same. So this is the LCD. So what you do, you compare this LCD with this one. What extra factor you have? 2. You have to multiply that extra factor here. So it becomes 2. And then you have minus sign. You compare LCD with this one. This is your extra factor. You have to multiply this extra factor here, which becomes the same. Yes? Okay, but still, this is a good progress because here I had 3 fractions in total, but here I have 1 and the whole thing 2 fractions. So it is a little bit simpler. But we should be able to simplify this. So let me ask your opinion about this. So the structure that you see here is a fraction on top and a number on the bottom. So if I want to write this as one single fraction, can you see what immediately I can do?
Multiply b by c.
B by C. So as Hasbullah did it quickly, this is something I expect you to be able to do it, okay? So A over, let me just justify it, why that is the case. Because if I want to do this division, I write A over B and divide it by C. But C means C over 1. But the rule is to write the first one, change this to multiplication, and write the reciprocal. And then you know that it becomes A over B. So these things, I really expect you to be able to very good at it, to be able to do it very quickly. So if I want to use this expression is playing the role of A, this expression is playing the role of B, and H is playing the role of C. So what can I do? I can write the limit. What should I write? I write A, this is A, and then I take this one and multiply it by H. 2 square root of 4 plus H times H, but I write it 2H square root of 4 plus H. Yes? And H goes to 0. Is that right? Okay. But now, this is what we actually practiced about in the previous chapter. When I want to solve limits of this type, of course, you know that when H goes to 0, the numerator is 0, the denominator, because of that, H is 0, so it is 0 over 0, but it is like infinitesimal over infinitesimal. So I have to write it and multiply it by the conjugate pattern of the numerator. So let me copy and paste everything so far, and then I multiply it by 2 plus square root of 4 plus H, 2 plus square root of 4 plus H, and H goes to 0. Okay? And now what happens? So this becomes the limit. This one should be multiplied in the numerator, but that becomes the conjugate rule. So it becomes the first 1 to power 2, which is 4, minus the second 1 to power 2. Is that right to write it like this or not?
Yes.
No. What is the correct way?
Oh,
Pair of brackets. I don't know how many times you want to fall into the same trap. Anyway, so divided by, in the denominator, don't multiply, because I want to have it in factorized form. I want to have it as a product so that I can simplify if possible. Yes? H goes to 0. But now let me do it with here. So if I open it up, it is 4 minus 4, but minus H. And 4 and 4 are gone. And then what happens? This becomes the limit minus H over 2H square root of 4 plus H multiplied by 2 plus the square root of 4 plus H. H goes to 0. Yes? Now I simplify things. I simplify this with that. So 1 times, this minus 1 times. So let me write it once more. So this becomes the limit of minus 1 divided by 2 square root of 4 plus h. And then I have 2 plus a square root of 4 plus h. H goes to 0. Now I can put it 0, yes? Do you want to be famous? Yes? Because I can name you on YouTube, yes? Don't talk. Yes? Don't talk. Yes? So, h goes to 0. What happens? This becomes 4, square root of 4, 2. 2 times 2, 4. Remember that, it is 4. And if I put h equals to 0 here, it becomes 2, 2 plus 2, 4. But what is the operation between them? Is multiplication. So the answer becomes minus 1 over 16. I have seen questions of this type in the national exam, so you have to use definition. But I will solve for you in a different way, which is a faster way. But the answer is minus 1 over 16. But the question mark is not f prime of 4, so the question mark is what? Is equal to 4 times f prime of 4 plus f of 16. So 4 is 4. This one I got now, which is minus 1 over 16. But plus, what is f of 16? I go to my original function, replace x with, okay, 4 times 1 minus 1 over 16, and then 1 plus 1 over the square root of 16. So it is very simple. 4 and 16 are simplified, so it is minus 1 over 4, and this becomes 1 over 4. So the answer is just simply 0. So the answer that you have to type there is just 0. And please do not type extra things, even if you see the space is bigger than just putting 0. That is not your problem. Some people write everything there. For you, it doesn't matter, but in the future, I have heard that they want to digitalize national exams, so what you type matters, actually. Even though I saw when I was checking your solutions, I saw many people got the correct answer, but they wrote this in the box. Okay, don't write that. The answer should be written. So don't see that, okay, this is so long, so let me write extra things. Yes, please?
1 over square root of 16. Oh, never mind.
Okay, but now because on Thursday we learned the differentiation rules, I want you to do it in that way as well. Because if this question with this structure is given in the national exam, no one will prefer to do it in the way I did. Unless they mention if f of x is 1 over square root of x, then use the definition of the derivative to calculate this. If the phrase of the definition of the derivative is not there, I don't even bother to do it in this long way. So now we have learned the new method on Thursday after I published the home assignment. So let me try to do it using the differential methods. Do you remember? I think the formulas are so simple, you have it hopefully in your memory. We have only 2 rows. Only 2 rows, f and f prime. Do you remember the first row was a constant? What was its derivative? 0. And the other one single formula, x to power a. If your function is of this form for any a, the rule, I didn't prove it, but I motivated you. This is the rule for any kind of exponent. This exponent goes down, x to the power of 1 unit less. That was the formula that we learned. Okay, now you can see that using this formula, I can more or less forget about this long process and do it very simply. But can you tell me what to do? Because there is still one obstacle in front of me, and the obstacle is that this is not in my table. This function is not in my table, yes? I can only use that table if I have a constant function or I have a power function. But here I have a third function, a radical function, a square root function. I have to change it, yes?
The day will be minus a half.
Minus a half. Why? Because hopefully you remember that the square root of x has another name. But still, this is not good enough because this is a fraction. I do not have any fraction rule there. So it motivates me to bring it up. So it becomes x to the power of minus a half. Now compare this one with your formula. What is a? A is what? Minus a half. No, minus a half. So f prime of x, according to the formula that you have it in the table, this exponent goes down, then it becomes x to which power? Minus a half, 1 minus 1. I hope that you can do this in your head. What's the answer? Minus a half, x to power?
3 halves.
3 halves. Minus 3 halves. So this is the derivative. Okay? But now I want to calculate f prime of 4. So I have to replace x with 4. But because some of us are very not good in using negative powers, I prefer to write it as positive. If you can manipulate it with negative powers, you don't have to. But for me, let me just do it in this way. I bring it down to make it positive so I can work with it better. Okay, but do you remember I told you there is a formula which is not in the formula sheet, is that the nth root of a box to power m can be written as that box to the power of a fraction. So that this goes up there and this goes here. So it means that if I compare this with the right hand side, box x is x, m is 3, n is 2. But do you remember whenever n is 2, we don't write it. Yes, that is convention for simplicity. So it's minus 1 over 2. I would write 1, but instead of this, I would write 2 here, x here, 3 here, but I told you when 2 is here, we don't write it. That's it. And now let us calculate finally f prime of which number I'm looking for? 4. So I put 4 instead of x after calculating the derivative. Be careful. So this becomes the second root of 4 to power 3. 4 to power 3 is 4 times 4 times 4, 64. But the square root of 64 is 8. It's minus 1 over 2 times 1 over 8. Yes? So it becomes minus 1 over 16. I hope that you agree with me. This is much faster than going through this whole process. Okay? But the rest of it is a copy paste of this one. So the only difference is that instead of calculating f prime of 4 in that lengthy way, we can do it in this way. Okay? Any questions? Okay, so now let us go to the next question. The next question is that if the line 9x minus y equals 3 is tangent to the graph of the function f of x equals to x squared plus ax plus 1 at the point on the graph whose x coordinate is 2, then what is this value of this missing a? Okay? Okay, so let me remind you of something that we learned about derivatives. That was Leibniz's method to find the derivative. Do you remember that? To invent even the notion of derivative. This picture is very important. I want you to have it in your memory all the time. So that was that if I have a function f of x, if I have the graph of the function, and if I have a point on the graph so that the x coordinate of that point is given to me, let me call it point T. If I draw a tangent line to the curve at that point, this has a slope, which I call it k tan, k of tangent. This is equal to f prime at this number. Okay, So this is what I told you you need to learn, you need to remember. This is the most important picture, but it doesn't mean it is hard, it's always this. Okay, so for example, if I say the slope is the derivative, it is not precise. The tangent at any point is the derivative calculated at the x-coordinate of that point. So you need to know it in this way. Okay, but now if you go back and read the question, here the tangent line is given to you. Okay, so that red line, pretend that, I'm not saying the graph is precise. No, the graph is not precise. We don't need to be precise. But you need to just imagine what is happening. So that red line that you see on the board is somehow being played by this equation. The function is given, but not completely given. And please don't get confused. This letter A is not the same letter A I used here. Yes? This letter A is different from that letter A. Okay? You understand that? Or if you want, I can. If it is confusing, let me change it to some letter B here. Okay? They are not the same. So here the formula talks about this coordinate, x coordinate. Okay. So let me write what we have here on the board. So the equation, the tangent, is given to you. It is 9x minus y equals to 3. So, and then a function is also partially given. Why partially? Because there is a missing part in the function which we don't know. Okay, but we know something. We know this function is tangent to this graph at a point whose x-coordinate is 2. X-coordinate of the point of tangency, of the tangency point, is given to be what? Is given to be 2. So this 2 is playing the role of what in this picture?
B.
Yes, thank you. So this is playing the role of this B. Okay, what I know K tangent is derivative. But for finding the K value of the tangent, I don't even need the derivative. Because the function, the line is given to me. If the line is given, I can read the K value without derivative. So let us do that. If I want to read the K value here, you know what, do you remember in Ma3c? We have to isolate y. So I move 9x to the other side, which becomes minus 9x, and then plus 3. I divide everything by minus 1 because I want to isolate y. If I divide this by minus 1, it becomes 9x. If I divide this by minus 1, it becomes minus 3. Yes? And now if I ask you what is the K value, it is 9. So this is the K value, but this is the tangent line. So this K value is the K of tangent. It is equal to 9. This is based on the information. But I also know from this picture, I can calculate the K value. On the other hand, this is on the one hand. On the other hand, K of tangent is equal to f prime of B. This we know. But what is B in this problem? 2. So this becomes f prime of 2. So then it means that I have to calculate f prime of 2 based on the information I have and put it equal to the K value of tangent from the information given in the problem, and hoping that using this I can find my unknown. So that is the strategy. Yes?
It's not a question.
Yes?
How you can do it, you can just keep talking.
Yes. Thank you very much. You stopped me and asked me to keep talking. Thank you very much. Yes. Very, very nice comment. I really love your comments. Okay, this can happen. Okay, but then I thought that because there is something here in this problem, in Natur group they actually mentioned that. I was thinking that you also wanted to mention that the same thing. because I will come back to it. You think for the time being before I complete the problem. We can't find it without the notion of derivative at all. In principle, this is one of those exceptions. This is a problem on tangents that we can solve it even if you are in Ma3c, which we don't know anything about derivative. Okay? So as I am doing the solution, if you know how is it going, you can in the meanwhile think about that alternative solution. How I can solve the same problem without even using the idea of the derivative. Okay, but now again, as I mentioned, I can calculate f prime of 2 in 2 seconds using differentiation rules, which I will do later, but my intention is to use this definition again to practice on the definition. So, this time I want to calculate f prime of 2. Remember, this is your function. So, the first thing I will do, I will write the formula for f prime of 2 using the limit idea. So, this becomes the limit of f of 2 plus h minus f of 2 over h. h goes to 0. Okay, so it becomes the limit. Okay, so let us fill it up because this is very simple. But again, when I say simple, I see still many students make mistake here. What is the meaning of this? It means go to your function, replace every x with that combination. It's very simple. I don't know why people even make mistakes. So I go there, I replace the first x with this combination. I have a power of 2. And I see plus a, and I see another x. That x should also be replaced by that. And then after that, I see plus 1. Okay? And then minus is in the formula. What is f of 2? F of 2 means that I have to go to the same function, replace every x with 2 this time. Just wait. So this becomes 2 to the power of 2 plus a times 2 plus 1. But the rest of it should be simple and no problems. I hope that you can do this simple algebra. So the first one squared is 4. 2 times the first one times the second one, 4h. The second one squared is h squared. And then I multiply a in, it becomes 2a. I multiply a in, it becomes ah. But here 2 to power 2, 4. Plus 1, 5. Minus sign goes in, it becomes minus 5. 2a minus sign goes in again, it becomes minus 2a divided by h. h goes to 0. What can I simplify?
4 and 5.
I missed something.
You missed the ones, but they.
Yes. No, but I have to write it properly. So there is a 1 missing here. Sorry. So 4 plus 1, 5, minus 5, they are gone.
Minus 1 in the end too. You forgot 1 in the end. The very
Yes, I put it here.
Yes, in the very end.
No, I added them. 5.
Ah,
Yes? And then 2a and 2a are gone. What is left for me is just simply limit of 4h plus h squared plus ah equals divided by h. I hope that you understand immediately what to do. What should I do? Yes, you factor h out. So this becomes the limit. H goes out. 4 plus h plus a divided by h. H goes to 0. Okay, and this h and that h are cancelled. And then you put h equals to 0. You get what? 4 plus a. That's correct. So f prime of 2 is 4 plus a. But this can be done in a matter of seconds. If I want to use the differentiation rules, I will do that. But let us go to the problem. So here, if I come back here, now you know the answer to the question mark. This is no longer question mark. The answer is 4 plus a. Yes? Now look, k tangent, on the one hand, it is given in the problem, is 9. K tangent, I calculated it using what I knew about derivative. It becomes 4a plus a. But k tangent is the same number. If I want to keep consistency, this number and that number should match. So this means that 4 plus a should be equal to 9. And it means that a is equal to 5. Okay? So this is my intention when I was designing the question. Yes?
Can't you just replace 2 with x and get the answer?
No.
Because I did the same thing and I got 5.
Okay. But then you get 0 points.
Yeah, because
Yes. It should be reasonable. So I can count up to 1, 2, 3, 5. Oh, 5. 5 is the number. Is that working?
No, because I replaced the 2 with like the x's
Mm-hmm.
in the function,
Mm-hmm.
and then 4 plus a 2 plus 1. That's 5 plus, yes, whatever. It becomes
Yes, that is correct.
becomes 5.
And that is exactly what I wanted to mention. But you have to be able to defend why this method works, if it works. It's not a coincidence.
But it doesn't work on the test because we need to use the formula.
No, because if this question is in the exam and you cannot explain, you will not get any points, just be randomly putting numbers there. So you have to precisely define, unless it is a multiple choice question or whatever.
Is if you give me this, exactly this,
Mhm.
if I reply with what you did here, I get 4 points.
Yes.
But if I reply with what I just said, like
Yes.
just replacing and doing that equation, do I also get points or do I not? Because I didn't do the
No, when I came to that, I will ask you to explain again. If I understand what you, because just randomly putting numbers without explanation, it doesn't mean understanding.
Okay.
So, of course, I will give you some partial points, because even if you don't know why it is working, it is working. Yes? But you need to be able to defend why it's working. But before going to what is Ahmad saying is actually exactly what I wanted to mention. But let me tell you that if this is given in the exam and the definition of the derivative is not mentioned in the formulation of the problem, don't do it in this way at all. Because there is a very simple way to do it before reaching to see what Ahmed is saying is true. Indeed, it is true. So let me clean this part. And now go back and use Thursday's lesson to solve the problem. Thursday's lesson tells me how to differentiate this function. X squared plus ax plus 1. Do you remember we had these rules before? But I told you there are 3 more rules that the book hasn't talked about, but it is always using it. What was the rules? One of them was called the sum rule. It means that if I have the sum of 2 functions and I want to differentiate it, I can differentiate the first one, I can differentiate the second one. This is called the sum rule. We also have a difference rule. It means that if there is difference, I can do the same thing. But one extra rule was that if you have a constant multiplied by your function and you want to differentiate it, you need to write the constant multiplied by the derivative. And if you remember, I told you don't push this analogy further, because some people say that if separately differentiating works for addition, works for subtraction, it might also work for multiplication. But this is not the case. So I wrote these formulas for you and crossed them over, meaning that they are not in general true. And for some reason in Swedish system, for understanding the correct one, you have to go to Ma3c. So don't push this analogy further. It only works for addition and subtraction. It only works for multiplication if this is constant, and forget about that, okay? Even for the multiplication, it doesn't work because the derivative of the constant is 0. Okay, now if I ask you what is the derivative of this function, the derivative of x squared uses that formula, it becomes 2x. The derivative of 1 is the constant number 0, so I don't need to bother. But what is the derivative of ax? What is the derivative of ax? A. Why? Because ax is a times x, and when I want to differentiate it, a is a constant. According to this rule, if a constant is multiplied by my function, I copy and paste it, and I differentiate x. What is the derivative of x? I told you, remember it, it is 1. And if you forget it, you have to do it again using this formula, yes? Because x means x to the power of 1. And if I want to differentiate it, according to the rule, 1 goes down, x to the power of 1 minus 1. But x to the power 0 is 1. But remember, the derivative of x is 1. So the derivative becomes just simply a. Yes? And if I ask you what is f prime of which number I want to calculate, f prime of 2. So I have to replace x with 2. So it becomes 2 times 2 plus 8. So it becomes 4 plus 8. And this number, this is the one exactly I got after those long calculations. So these are the solutions to this problem. Again, if the definition is not mentioned, use this one. But what Ahmed said is completely independent from even talking about derivatives. Okay? So let me pause this and clean. So, and now let me solve what Ahmed said, and we want to understand why that method actually works without even having to know the notion of derivative here. Because you know that when I ask you to remember this diagram, which is very important, I told you that the k value of the tangent line is what? Is the derivative calculated at the x coordinate of the point of tangency. But remember, this point is always on two functions. One function is the curve that you see. Another function is this line. This is still a function. That's also a function. So if t is the point of tangency, remember this as a remark. So let me write the remark. So the coordinates of the tangency point satisfy both the equations of both the function and the tangent line. Okay? So it is important to remember this remark, even though for a person who really knows what the function is, I don't need to write this down again. But this point is on the curve, so the coordinates will satisfy the equation of the curve. This point is also on the line, so its coordinates should satisfy the equation of the line. Okay? And in this problem, what was the x-coordinate? This x-coordinate was given to me from the beginning. So now I want to find the y-coordinate of this point t. I can use both of them to find the y-coordinate. So I would say that the y-coordinate of the point of tangency is equal to f of 2. Do you agree? So let me write it like this. T is a point whose x-coordinate is 2, the y-coordinate is missing. Yes? Okay. So T is 2 and y of t, because this x-coordinate is 2, the y-coordinate is unknown. But I know that this is on the line, and it is also on the curve. Because it is on the curve, it means that when I go to the equation, replace y with yt, replace x with the x-coordinate 2, that equation should hold. But also, if I go to the function to the line and do the same thing, it should also work. So it means that if I go here, I replace x with 2, the x-coordinate, and minus, instead of y, I put y of t, it should be equal to 3. And this is a system of two equations okay, in two unknowns. What is my second unknown? Is this 8 that I don't know. So I will continue. What is f of 2? F of 2 means 2 to power 2 plus 8 times 2 plus 1, which becomes 4 plus 1, 5 plus 2a. So this means that y of t is equal to 5 plus 2a, but still, unfortunately, I don't know any of them. But from here, I can find my y of t. 9 times 2 is 18. I move it to the other side. So minus y of t is 3 minus 18, which is minus 15. So it means y of t is 15 itself. Okay? And then I put it back here. So 15 is equal to 5 plus 2a. I move it to the other side. 10 is equal to 2a. And then again, you see 5 is equal to a. And that is also the correct answer. And here we really didn't use the idea of derivative at all. Okay? That is also a good thing. In the new homework that I have published in 1 hour ago, so you can see a lot of questions of this type that you have to understand. That a point is sitting on the curve and it is sitting on the tangent, so that you can be able to see. Is this solution understandable?
Yeah.
Yes, so I have a point which lies on two functions. The coordinates should satisfy the equation of both of them. And then I solve the system and find the answer. The final question now here, we go to the final question. So in the following picture, the blue curve that you see here is a part of the graph of a function f. Usually in these kinds of questions, you have to use the information given on the picture. For example, you need to assume that this line is tangent to the curve of the function at point t. Yes? Of course, it didn't hurt if I just emphasize on it explicitly. Okay, anyway. And then if f of 4 is 25 and f prime of 4 is 1.5, then the y coordinates of the point A here is equal to which one of these numbers? Okay? So let me draw a little bit of this, sketch this graph on the board. Okay, so when I did it in Natur group, one of the students actually proposed a better solution than I did. So let me just present his solution to you. So, but let us try to understand the problem. So here, this is the curve, and this is the straight line tangent to the curve at this point t. The x-coordinates are only the ones given for a, t, and b. With these information, we are supposed to find the y-coordinates of the point a. Yes, that one. So, in order to find the y-coordinate of a, actually I was trying to find the equation of the line, but actually Joshi introduced a better way. So I will follow his. So that is shorter. Yes?
If you introduce like making an equation, like 1.5 is equal to 25 plus what, something like that.
Oh, so you have to be a little bit detailed because I didn't understand what you mean. But he said that we use the formula for yk equals to delta y delta x. As simple as that. Why? This is a very good idea because one thing that you understand, if I ask you, can you read the coordinates of t for me? Of course, the x coordinate you can read immediately, 4. But what can I read for the y coordinate? This t is on two graphs. The tangent line is useless for me because I don't know anything about it. But the function, I still don't know anything about it except I know what is f of 4. F of 4 is exactly the y coordinate of this point, and it is given 25. So it means that I already know what t is. A, that I am interested in its y coordinate, the x coordinate is given to me. The y coordinate I don't know, so if you don't mind, let me just write it y of a, but I know this is missing, and the question asks me about that. How can I use this piece of information? This line is tangent to the curve at this point. I told you f prime at the point of tangency, at the x-coordinate of the point tangency, is the slope of the tangent line. So f prime of 4 equals to 4, f prime of 4 equals to 1 comma 5 means the k value of the tangent line is 1 comma 5. This is based on the information given in the problem. Okay, so this is the f prime of 4 is the k value of this tangent line. So k of tangent is 1.5 according to the information given in the problem. But because these 2 points are on this line, in Ma3c we learned how to find the k value if we have 2 points. And that is k value is delta y delta x. Delta y is y in final. For example, let me consider t is the final point. Let me consider a to be initial. So it becomes y initial divided by x final minus x initial. But k is the k value of this line, which I know because of this piece of information. So it is 1 comma 5 equals to y of t, I know it, it's 25. Y of a is the missing one. X of t is 4. And x of a is 3 comma 8. So 1 comma 5 is equal to 25 minus y of a. And this one is what? 0.2. I multiply everything by 0.2. 0.2 times 1.5 is what? Is 0 comma 3. And this is just simply 25 minus ya. So I move ya to the other side. I move this to the other side. So 25 minus 0 comma 3. So it becomes 24 comma 7. So the missing number is 24 comma 7, which of course it is not given exactly in that form, and everyone understands that this is exactly that number, because if I divide 247 by 10, it becomes exactly 24 comma 7. Yes?
When you find y and I do it like this, for example, you say from 3.8 to 4, it increases, I don't know exactly what, let's say
0.2.
Yes, I mean in percentages, it increases like what?
Well, that is just delta y delta x you are talking about. It means that this means that I go to 0.2 units forward, and then you measure what is the change in y. That is delta y delta x. That's the same idea. Yes, it works.
So it increases with 1/19 part, so I do the same thing.
Yes, that is exactly that word.
Oh, okay. Just written in the
Yes. Any questions?
No.
Okay. Thank you.